them. Let me find it real quick. So it says the latter formula will result in excessively large sample sizes if p is small or large. Otherwise, the results for the two equations will be fairly similar. So is it saying that sometimes you can't use the second equation?
Yes. If they don't give you a p,
that's the only time we use it?
Yes. Then you can use the other one.
Okay.
With what he said in the video. Is when you should use the other one. And the other one kind of, it is larger usually. Because it errs more on the conservative route than the actual equation does.
Okay. All right, I'm ready then for the quiz.
All right. So the symbol for the true population proportion. I didn't even write
this one is what I gave.
It should be C, just P.
Hat, so it's just P.
Yeah.
Yeah,
it's definitely not A, so.
P equals true population proportion. All right.
C.
Next one. The requirements for constructing a confidence interval are satisfied. Oh, so we have to do the little equation here.
Yeah. They will give 10. Oh, let me see. I was
100 times
10.
Hat.
1.
Well, it can be
10.
equal to.
It can be equal?
Yeah.
That was my question.
It's greater than or equal to. That's what the sign says.
Equals times. Okay, so it's yes because it's 10 and 90, right? Is that what you guys got?
Yeah.
That's what I got.
So number, is Monica, you on board too?
Yeah. Yes. True.
Number 5. The requirements for conducting a hypothesis test are satisfied, and the requirements are simple random sample, and it has to be above 10, right?
Yeah.
So if I understand, they are the same as the other ones or not? Like it's the same formula?
Yeah, they are the same formula, but in one you're taking P, and in the confidence interval you're taking P hat.
Yeah, okay.
Is what you've got to do.
Oh, confidence interval is P hat.
Yes, so that's why in that categorical data analysis Excel spreadsheet that they give us, it has the two. It has the hypothesis and the confidence interval in there.
Okay, yeah. So when conducting a hypothesis, we use the P like the normal.
Yeah, so for the confidence interval, we use the P hat, and for the hypothesis test, we use regular P. So here we are with the hypothesis test, so we use regular P.
Oh.
Okay.
And there's still both
okay, let me write this down. Okay, so this is confidence interval.
So the first one we did was confidence interval. And the confidence interval was just taking
the n times the P hat. Right.
Yes.
And now we're doing the same equation with just P. So if it's a hypothesis test,
you just need 100 times 0.25.
N times P, etc., not P hat. All right, then let me plug it in just because. So N times P is 0.25. Would be 105 is 25, and then 1 minus 0.25 times 100 is 75. So okay, still true, but I'm glad you pointed out that there's a difference between a hypothesis
there
test
is. And so what I did is I went ahead and just wrote underneath what both of those in that Excel spreadsheet. I wrote underneath the equation so I remember that which one's P and which one's P hat.
Okay. Thank you.
So use the following for the next 5 questions. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 were found guilty. So the point estimate is, I think that's where we just divide 45 divided by 60 or something, right?
Yeah,
Correct.
I got 0.25, but 75, sorry, 0.75.
Yeah.
Yeah,
So it
0.75.
should be, and it wants us to round it to 3, so might as well add another extra 0 in there to be safe.
Okay.
Yeah, I'm not going to add zero. Okay, next one. Create the 95% confidence interval for the true
This is where I get
proportion of
confused.
first-degree
So we're determining the margin of error.
So the confidence interval, do we plug that in this Excel sheet and we get 64 and 86? 0.64
Yes.
off and 0.86 off.
But the questions they're asking,
Okay.
for question 7 is the margin of error.
Which isn't in the spreadsheet, so we have to do that by hand, right?
Yes.
Okay. Okay.
And I figure at this point we got to use P as 0.5, right? Because they're either guilty or not guilty.
Yes,
Okay.
Okay.
I agree.
Or we
I'm
also,
taking-
yeah.
Okay.
So margin of error equation is the z times
19.96.
error.
Wait, so we're using P, not P hat, right?
Yeah, we got to use P, and they don't give us
Okay.
P hat, right? We calculated at 0.75, but in the equation calls for P, and a P I would assume is 0.5, right? Because it's either not guilty or guilty.
Yeah, I guess, yeah.
Is everyone following me?
Yes.
So it's 1.96 times the P, which is
0.5.
So is 60 N? No, 45 is N, right?
Are you sure we're not doing it
60
with
is N. The sample size is 60.
Oh, okay.
You could
What
do, so it's
calculation are we
essentially because we're doing the margin of error.
Which is that the z times square root of P?
P 1 minus P N, and really that P 1 minus P N is the standard deviation. So if you were to calculate the standard deviation and then just multiply it times the z-score, the calculated z-score, remember, which should be the 1.96, right? So not. We should get an answer of 0.1265.
65? Okay, I got
How
that.
come what's your P though? P is
1, 2.
You're right. They don't give us the P, but in this case, we can assume that P is 0.5 because it's they're either guilty or not guilty. So it's either one or the other. So it's a probability of a 50% chance. So
and we do that over the number of 60.
you got it.
So I got,
It feels like to me we should be using P hat. So I don't really get it, but I'm going to plug this
I know
in
it
anyway.
gets so confusing. It gets so
for the
confusing.
confidence interval.
Oh.
But for the
Okay,
margin of error, we just,
Okay, 0.5 times 0.5 equals divided by 60 equals, and this is
I got 0.1265.
Yeah, I wrote 1, 2, 7.
Yeah.
Okay.
yeah, I got something completely different. So I'm doing something wrong. The z, so it's just 1.96 times the square root of 0.5 times 1 minus 0.5 over 60, right?
Yeah.
Yes. So there must be a parenthesis error. So you have an error of operations, I'm guessing, somewhere
Let
in
me
your.
try it
Yeah,
again.
but just make sure you have parentheses around the 1 minus 0.5 and then also around the whole top part above the 60.
Yeah.
All right, let's do it. Square root of another parenthesis 0.5 times
And then in
0.5
the parentheses.
parenthesis divided by 60 parenthesis. I got it now.
Yay!
All right. I still wonder if this is right. This will be interesting to see if this ends up being right because I would have done P hat. So
So what you calculated, right? But the equation says it's P, not P hat. So
Yeah.
Yeah, that's what I wrote down for the equation.
So you did it 0.127, you rounded it up?
Yeah.
Yes.
So then it's, I'll read 8. Input the lower bound. So it's 0.640.
Yes.
Okay, so then I have to go into,
Numbers.
Yeah, now you got to go into that categorical data analysis and input everything.
So our null hypothesis, what do we put for that? 0.5?
The null the 0.5, you got it. Yay, Charity!
Yay. And then for the type of test,
I'm guessing it's just not equal to, but this, because it's, and I always double check and just click around, that really only affects the p-value if we do greater than,
Yeah,
less than, or
that's
equal to, so it's not going to affect the other ones,
Yeah.
so we're safe, even if you left that alone.
I have a question. What did you put in the null hypothesis?
Plus 0.5 again, which is what we use for p.
Oh, yeah, because that's the p.
You got it. I almost feel like I should put on the side that p equals null hypothesis, because that's what they were telling us that we should write now, right? Is the p equals the value, and then, yeah, the p is the null.
Okay. and
so the confidence interval, what did you guys get for the lower bound?
0.640.
0.640.
640, that's what I put, okay. All right,
Okay,
yeah,
then 9.
let's go to that. Yep.
Input the upper bound. So it's 0.860.
Yes. Yes. That's what I got.
0.860. 0.860.
The question 10 says, if you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? The width, I think, decrease?
Yeah.
It should decrease. Okay, I'll go ahead and take 11. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose that p equals 0.5, 1/2 or 0.5. What is the smallest n can be, and both requirements still be met? So if our p is 0.5, and I would assume it's 20, right? Would be double that. So yes, 20 is that one.
I don't remember what formula, like I just do my calculations in my mind, but do we have formula for that?
It is. So in this case, it's the two formulas you have to do. So in this case, it would be n times p. So it would be is greater than or equal to 10. So if we just go equal to 10, we would just take the 10 divided by the 0.5 that we know p is, and we would get 20, and that would give us n. And in this case, it's really easy because if you do the n 1 minus p, that would just be 0.5 again as well. So it would just be
This
that
is not
same
making any sense to me. I thought this is the formula n equals z over 2m squared.
N equals z over 2m.
It says,
Oh, the sample size formula?
suppose p is this. What is the smallest n can be? Both requirements will be met. We're not doing.
Yes, but we can't use that one because that requires us to know a confidence interval. And on this case, it doesn't give us the
It
confidence
says if
interval.
we don't have a prior estimate, but m is the margin. Oh, so it's not even telling us the margin of error.
Yeah, so we don't have the margin of error either. This is we're going back now to the formulas from the previous lesson on Tuesday now.
Yep.
So we're just doing n
Or the
times
previous question.
p greater than or less than 10. It's all we're doing.
Mm-hmm.
Yes.
You got it. Mhm.
Okay, so
In
0.5.
this case, we don't know n. So we're solving
instead
for
you
n.
solve for n, so you divide the p, so 10 divided by p, which is half,
Is
10 divided by half is
but we have to do the other one too. So hold on. 1 minus.
Okay, and then the other one is 100?
You got it, because it'll just be the 0.5 or the 0.1, right? Divided by, or 10 divided by the 0.1, which is equal to 100.
So we divide and then we multiply by 10. Am I right?
Why is it 0.1? Why are you?
wait, what?
How is that?
you're-
What do you mean divide by 0.1?
So on question 12, it says suppose equals p equals 1 divided by 10. So 1 divided by
Oh,
10.
you're on a different problem than me. I was
Oh.
on the one before. I was trying to do it both ways. both
Okay.
ways. And is it just 20 both directions for
Got
number
it. In
11?
this case, because it's 0.5, yeah, it's 20 in both directions. This
Okay.
other one, it will get it a little different because it's the 0.1 now.
Okay, what is the smallest n could be? So now we have to put in 0.1.
Yeah.
And so 10 divided by 0.1 is 100, and then the other direction it would be 1 minus 0.1.
So 0.9.
So 10 divided by 0.9 is 11.11111. Right?
So that's the answer then, right?
Yeah.
The 11.1111.
Well, what is the smallest? Yeah, so it's 11 point.
So the smallest would require that we have to do that 100. Because we could get, with the other equation, we could get away with 11, but to satisfy the other one, we have to do at least 100. So it would be 100.
Except it says round up. Doesn't it? Oh no, that's something else. Never mind. Okay, so 11.111 is what we put.
No, the answer is
No,
100.
100 is the answer.
Why?
Wait, why is it 100 if that's the bigger number?
Because what's the smallest? Oh, for both requirements.
You got it. We have to do both. To satisfy both requirements, we have to do at least 100.
Because 11 point whatever, it's not going to be. It's going to be too. It's not
Well,
going to
not
be
enough
okay.
for, yeah.
I get it now.
Got it now? Okay. That's where it gets tricky.
Okay, I'll read the next if you want.
Go ahead, Charity.
For the water quality study and reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using the significance level 0.05 with the following hypothesis: P equals 0.6, then alternate P is less than 0.6. They collect new data, and this X equals 38 indicated health. The conditions for a hold up, let me.
So in this case, we need to go to that categorical data analysis Excel spreadsheet, and they've given us X, so we can put in 38 for X and 80 for N. We can ignore the confidence interval right now, and then we put in the null hypothesis as 0.6, because that's what they gave us up top.
So since we have the null hypothesis, we can do it on the chart instead of doing it by hand.
Got it, by hand.
Because
And then we would be able to look at those numbers in those 4 quadrants, in those 4
Yep.
blocks, and they're all over 10.
I got lost. What are you doing? Like, what?
So we're on question 13.
So you
We're
said no.
inputting the numbers into
And we're
the.
inputting the numbers into the Excel spreadsheet, and X, we should input a number of 38, and N, we should put and the confidence interval we'll leave alone right now, and then
38 and 8.
6. And then we should go ahead and put in, because our alternative hypothesis is less than, so we just should go ahead and click that to less than right now before we forget.
Just let me do that. So it's 80 and 38 and 80. So then you
38,
get
80,
Wait, what?
0.95 and 0.60
Yes.
and less than.
0.95, and then 0.6, and then less than. Should all be in that little input cells over there.
So we get 38 and 42 for the confidence interval requirements.
Yeah.
Yes.
Okay.
So, but the question 13 asks about the hypothesis test requirements, which are 48 and 32. So we're fine there.
Okay.
So yeah. So
Okay,
true.
go ahead, Charity. I took over for a moment. Your turn.
Good. So for question 13, we're putting true. They're met. So greater than 10. And then 14. What is p hat? 0.475.
Correct.
Yeah.
Is that in the, so we don't need to
Yeah,
do
they
it by,
actually say p hat. So I typed in and then did the p and then the little caret above. Because I was like, they don't give us that. And I tried to calculate it, but which is easy to do. It's just 38 divided by 80 is p hat.
Yeah.
So
but it's given. That's good. Okay.
And then find the test statistic. Which one is that?
That should be the z-score, the negative 2.282.
Okay, so negative 2.282, yeah.
2.282.
Okay, and so now it wants us to make a decision. So now we're gonna have to go click over to the applet.
2.282.
Oh wait,
It
what?
wants
Hold
just
on,
than, less than. So if I put a negative 2.282 and just highlight what's to the left,
I can hear.
I get an area
So the
of
p-value is
0.112.
1, yeah.
Oh yeah, they give us the p-value. Huh. I put it in the applet, and I'm doing all this extra work.
Oh, I was like, what? Yeah, it's just
That's
in there.
funny. It is right there because we put it in.
Okay, 0.011.
Okay. So I couldn't hear you, but 16 is 0.011?
Uh-huh.
Huh?
Yes.
Oh, yeah, 0.011.
So what is the decision for this test? We reject.
Our
Reject
level
it
of
'cause
significance
it's
was
less than 0.05.
0.04.
So we reject.
Yes.
Yeah. Now it should say we have sufficient evidence to say.
D.
I think it's D.
Yeah, I think so too.
Yes. Because it was less than the area that the area has decreased.
Yeah.
Everyone okay with that? Are you following with us, Melody?
Yep, I'm set.
Okay. I hadn't heard from you in a while, so just want to make sure you're still there with us.
Yeah, I'm a little
Okay, I'm going ahead and reading the quiz real fast. That's okay. I did the homework because I was like, this is just not, I was so confused with the P's and the P hats last night. It was just, it's like my head was spinning. Oh. Okay, we missed 2.
Okay, I bet one of
Oh,
them
which
was number
one?
7. Was 7 one?
Let's see. One of them is number 7. The margin of
Yeah.
error is not 0.127.
I think we're supposed to use P hat.
If you
Okay.
look in the lesson.
I know, I'm really confused about it. And then the last one, oh, that was my error. It says, what is the p-value for this test? And I put in the z-score again.
Wait. For number 16?
Yeah, for number 16, I put in the z-score twice. I don't know why I did that.
It's supposed to be 0.011 for that.
It says around a 3 decimals.
0.011. Is that not rounded?
It should be, oh, yeah, duh, hello, there's a 0 in there. Oh my goodness, wow.
In the lesson, it says that the formula for margin of error just uses P, not P hat. So I don't
And
know.
that's what we
Yeah.
did.
It says,
Yeah.
Charity, say that again.
In the lesson, it says the formula for margin of error, it uses P, not P hat.
Margin of error.
I'm really confused. Yeah, that's number 7 that we got wrong.
All right, let me look at that. Create the 95% confidence interval for the true proportion. Okay, input your answers, lower and upper bound. Determine the margin of error. So, I mean, I would have put in P hat, but
But in the
Well, I guess
lesson,
go ahead and do it with P hat and see what number we get. And I guess we should put it in there because at this point, I have no idea what else to do.
yeah.
Because that's the only
That's what
equation
we
that they
did
gave us.
with
And we all got
P.
the same, unless we had a rounding error. But I mean, we rounded, I thought would be right. So,
Yeah.
because we got
let me read
0.165.
the problem
So,
again. The problem
There's a
says study of
95%
first-degree
confidence.
murder trials were conducted. A random sample of 60 people were on trial. 45 were guilty. 45 of the 60. Find the point estimate, and that's how we did that. Yep. Then create the 95% confidence interval.
Maybe we didn't use the right P number, like, maybe it's not 0.5 like you thought.
Why would
Yeah,
it be
maybe it wasn't
0.5?
0.5. Because it's either
Why would
guilty
it
or
be-
not guilty. There's only two options.
Oh.
You're either guilty or you're not guilty. So that's why we got 0.5. Because they did the same example with like the election. You either vote for this candidate or that candidate.
Hmm. Maybe.
I'm gonna see.
Well, I'm gonna calculate out p hat. Just
And
do it.
yeah, go for it. You p-hat and see what you
Yeah,
get.
do it because I don't know
That's
what
the
else
only
to
thing
do.
I can think to do is put in, if we calculate by p-hat and try that number, because I'm really confused now at this point.
So it would be 1.96 times the square root of 0.75 times minus 0.75. 6. So .75 times 0.25 divided by all right, so I got 0.1095, 0.110.
Do that one. It is that one. Because I did that cheater test that we did last time. Remember where you took the low bound and the high bound and subtracted them and divided by 2? And I get 0.1094. So I wonder if it is 0.109. Then why would they give us the stupid formula? Wow.
I don't know. That's what I'm saying.
Well, except that mine was
9.
10956, so mine rounds up to 0.110.
110. So it's up. Go ahead and put 110 if you want to, and see. And I guess really you should just. Oh, they don't give us the mean. Dang it.
Let me plug it in my
You
calculator
can
one more
double check
time.
it.
Let me plug it in my calculator one more time. Just make sure
Here, I'll
since I'm not
plug
very
in
good.
mine too, and so let's see if we get the same.
Okay. Square root of extra parentheses 5 25 divided by equals 1.6.
So did you get 0.109566?
Yes, and that would round up to 0.110. Okay, unless we think there's something else we should do you want me to just submit this answer?
Wait,
Which one are you putting? You're doing 110, right?
Yeah.
Yeah.
Okay. Go ahead and submit with 110.
Oh, it says fine. You know, that was question. Wait, what question is this?
7?
7.
Oh, I plugged it in the wrong thing. So hold on a second. What was the answer to question number 6?
6 is
6 was 0.75.
Okay, hold on a second. 0. I put the answer in the wrong spot, but I didn't submit it yet. So
No.
all right, so 0.1 was 0, and sorry, 6 was, say it again, 0.75,
75.
right?
75. You can add that other 0 if you want to be safe, but it took it.
It's just gonna get rid of it in the end.
All right, so now I think I've got everything. 0.75.110, I'm submitting. Save, go to submit. Submit, and yes, submit. That's 100%.
All right. So it is 110.
Well, then I'm not sure what to do for the normal equation.
So then we use p-hat?
And she used p-hat rather than p.
Yeah.
Okay, so I guess maybe the book is wrong. I kind of want to email the
I
professor
think
about that.
when there's two numbers where it's saying 45 out of 60 or 3 out of 7.
We can calculate the p-hat. We should take the calculation for p-hat when they don't give us p. Maybe that's what it is.
Yeah.
I think so.
Maybe.
But if they give us
Okay.
P and we have a P hat, then what do we do?
Yeah.
Then it's a good thing he gives us 2 attempts on these quizzes.
Kayleen, do you need us
Exactly,
to read
right?
back the answers to you?
No, I wrote them all down while you were doing the calculations, so I'm good.
All right. Well, do you want to submit it before we move on to our
No, let's go
Or
ahead.
other-
Let's move on.
okay.
Okay.
So,
I should pull up the email.
really like your list. Way to go.
Yeah.
That you found, Melody. That's great. I think the only thing that was in the description that you emailed is that rather than doing 7, I think we should take every third, because this list really is not that long.
Okay.
Yeah, I was
That sounds good.
So the description I wrote in for the professor to understand what we're doing. This website has the blah, 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 the food categories. From this list, we will take a systematic sample. We'll roll the dice to find a starting point, and then take every third sample until we have 40 categories, or 40 items, I guess I should say, rather than categories.
I'm gonna pull up this document. I don't have it in front of me. The final project design.
Okay.
All right, here it is. But we can't. Oh,
Because I sent you another draft this morning.
all right. Well,
Yeah,
hopefully this
I-
is the.
It's the one that you sent to when Charity was asking about the project.
Yeah, right
Yeah,
after
all right,
Charity emailed, I sent another one out, and this is draft 2.
Yeah.
So I think we should be pretty good with this one.
Yeah, this is draft 2. Okay, hold on. It's opening up. Just 1 second.
I guess we should start at the top and make sure we're all right, because one of us
Yeah,
should
let's
probably
go-
submit this today. I'll probably submit this today.
Do we all need to submit it?
Where do we submit it to?
You have to go down
Do
to the
we
final
all-
project, and well, that's what I don't know. So hang on, let me click over there real fast.
Like, I was looking and I was like, where do I even submit this? Like, I have no
Okay,
idea.
so if you go to our
do
table
you
of
guys want
contents, it's
To
still on the bottom.
stop the recording, or should I continue the recording?
Oh yeah,
Oh, you
no, I would stop it.
Yeah, let me stop the recording then. Okay, stop broadcast.